In the previous video, I discussed why this proposition and proof were both correct. Now, let's move on to the same proposition, but an incorrect proof of it. Okay, so the thing that's incorrect about this proof is that the prover assumed that x and y are in fact the same odd positive integer. And that's not what this is saying. This is saying that no matter which two odd positive integers you choose, when you add them, the result is even. But this proof really just proves that for all x, x plus x is even. Okay, I know. Anyway. Right, here's the issue. Right, so assume x is an arbitrary odd positive integer and y is an arbitrary odd positive integer. That's correct. That's just stating the assumptions. The issue is that we say that x equals 2n plus 1 for some arbitrary integer n, and then we say it again. There and there. Right, so think about this, right? If x equals 2n plus 1 and y equals 2n plus 1, then you can say that x equals y. Right, and so then x plus y here becomes x plus x. And that's too specific. When I would give Math 189 students proofs to do in previous classes, and they would do something like this, I would take points off slash and then say something like too specific. And of course, they would always say, what do you mean by too specific? And then I would give them this explanation that I'm giving you now. Okay, so it's just too specific. All right, so then the question is now, what is the correct thing to select in the answers here? And so the proposition is true, but the proof is incorrect. So which one of these, which of these reasons, not which one of these, which of these, because more than one could be, more than one of these 5 selections here, 1, 2, 3, 4, 5, could be correct. All right, so the only one that applies here is 5. There's a sentence in the proof that does not directly follow from the sentence that came before it. So there's not there's not logical flow. All right. To say that x is to move from this line, oops, sorry about that, to move from this first line to the second, logically, just because x is an odd positive integer and y is an odd positive integer, that doesn't mean they're the same odd positive integer. So that's flawed logic. The second line doesn't follow from the first. You'll see that we didn't provide a finite number of examples when there's a universal quantified statement, so that's why that one's not correct. Okay. A rule of logic was used incorrectly. You'll see an example of that later. The equations in the proof are all correct. Let's look at that. Okay, so the equation used in the proof, get rid of this. the equation used in the proof, this equation, oh man, this equation right here, it's true that 2n plus 1 plus 2n plus 1 is 4n plus 2, which is equal to 2 times 2n plus 1. That's absolutely correct. That's correct math. You're just using, you're just being too specific. You're not really proving that x plus y is even, no matter what x and y are when you choose from odd positive integers. You're proving that x plus y is even. This right here is proving that x plus y is even when x and y are in fact the same odd positive integer. Okay. It's not that one. It's not that one. Not all the variables have been defined. It's also not that one. Let's see why. So we did, in fact, define what n was. N is an arbitrary positive integer. And we did, in fact, define what n is. N is an arbitrary positive integer. So n was defined properly. So that's why it's not that selection either, 4 there.